Caviño Square, an innovative strategy in using the concept of proportion to solve percent problems for grade 6 pupils of Trece Martyr City Elementary School during the school year 2019-2020, basis for an action plan. Originality and value. Some competencies in mathematics that pupils are having difficulties at Trece Martyr City Elementary School are of ratio and proportion, and the percent problems. It is evident in the list learned for the second quarter of school year 2018-2019, wherein the competency solves percent problems such as percent of increase, decrease, discounts, original price, rate of discount, sale price, markup price, commission, sales tax, and simple interest was the least learned, which has the lowest mean percentage score of 61.36%, or only 27 out of 44 pupils got the correct answer. Originality and value. According to Jitendra Star-Dupois Rodriguez in 2012, one explanation for this lackluster performance is students' difficulties with proportional reasoning. Fujimura, 2001, Lobato, Ellis, Charles, Zivek, 2010, mathematics researchers agree that proportional thinking, reasoning with ratios, rates, and percentages is critical to the understanding of advanced mathematics. It provides the bridge between the numerical, concrete mathematics of arithmetic and symbolic algebra. The example is Fuson and Abrahamson in 2005, Lemon in 2007, Lesch, Post, and Baer in 1988, and furthermore, proportionality is closely associated with real-world applications and for understanding many problems in science and technology. Karplus, Poulos Stage in 1983, and Low Watanabe 1997, Turner, and Poulos in 1985. Purpose. The primary purpose of this study is to determine the impact of Caviño Square and innovative strategy in using the concept of proportion to solve percent problems for grade 6 pupils of Trece Martyr City Elementary School. Research questions. Specifically, this will answer the following question. 1. What is the result of pretest mean scores in mathematics of the participants of the study? Second, what is the result of post-test mean scores in mathematics of the participants in the study? Third, is there a significant difference between the pre-test and post-test mean scores in mathematics of the participants of the study? Design and methodology. This study used an innovative strategy named Caviño Square. A pre-experimental research design which used a group of 45 participants was used, wherein participants were given pre-test before a week-long lesson in mathematics about percent, using innovative strategy Caviño Square. A post-test parallel test was given after the lesson. Design methodology. Pre-test and post-test mean scores and standard deviation were computed. Comparative test results on pre-test and post-test was used to test its significance. Ethical issues. The researchers assured the anonymity and confidentiality of the data gathered. Scoring guide for pupils' academic performance, mean scores and descriptive level. 18 to 20, excellently mastered. 15 to 17, highly mastered. 10 to 14, somewhat mastered. 6 to 9, poorly mastered. And 0 to 5, not mastered. Findings. Research question number 1. What is the pretest mean scores in mathematics of the participants of the study? Table 1, pretest mean scores in mathematics. N is 45. HPS is 20, HS is 10, LS is 1, mean is 6.56, and ST is 2.21. Pretest shows that the participants have poorly mastered the competencies in percent. Findings. Research question number 2. What is the post-test mean scores in mathematics of the participants of the study? Table 2. Post-test mean scores in mathematics. N is 45, HPS is 20, HS is 20, LS is 6, mean is 12.38, and ST is 2.89. Post-test shows that the participants have somewhat mastered the competencies in percent. Findings. Research question number 3. Is there a significant difference between the pre-test and post-test mean scores in mathematics? Table 3, a comparative t-test results on pre-test and post-test mean scores in mathematics. Number of cases is 45. Computed t is 13.32. Degrees of freedom is 44. Critical values of t is 0.01 is equals to 2.704. 0.05 is equals to 2.021. Interpretation, significant at 0.1. As reflected in the table, the computed t-value of 13.32 is greater than the critical value of 2.704 at 0.10. 0.01 level of significance with 44 degrees of freedom. The null hypothesis is rejected in favor of alternative hypothesis. This means that there is a significant difference between the pre-test and post-test mean scores of grade 6 pupils in mathematics. It implies that there is a significant increase in the level of mathematics performance after the utilization of Caviño Square. Conclusion. Based on the findings presented, it is therefore concluded that Caviño Square is an effective innovation in solving percent problems to enhance the performance of grade 6 pupils. Recommendations. Utilize the Caviño Square innovative strategy to improve the performance of pupils in solving percent problems. Administrators should encourage teachers to employ the Caviño Square innovation in teaching competencies about percent. Recommendations. Similar studies should be conducted using larger samples so that more general conclusions can be drawn regarding the Caviño Square innovation. A comparative study regarding Caviño Square innovation and the current norms in solving percent problems should be made to further validate the effectivity of the innovation. The proposed action plan for this study is highly recommended for implementation. Thank you.